They've frustrated you, and they've cost the world billions of dollars. Today we're going to talk about bugs. Welcome to Kopec Explains Software, the podcast where we make computing intelligible.
This week, Dave, we're going to be talking about bugs. And before we dive into what they are, can we talk about the origin? How do we start calling them bugs?
A lot of people think that bugs come from the idea of insects getting caught in computing systems, literally, during those early computers that were the size of a room. And in fact, there really is a story about that. But the term bugs actually goes back to before the time of computers. In early engineering systems, when there were problems with them, they would call them bugs. In fact, there's documentation of Thomas Edison talking about one of his electronic devices and the engineering of it. And the problems came up and were referred to as bugs. So the term comes from before computers. But those first computers in the 1940s and the 1950s, they had some great anecdotes about actual insects getting caught and causing problems. Remember, these were huge machines that would have vacuum tubes and electronic relays, and they would take up sometimes the size of a house or certainly the size of a large laboratory. And one of the most famous programmers of all time, her name was Grace Hopper, she actually had a particular incident where a moth got caught in the computer that she was working on. And so this is sometimes seen as the origination of using the term bug specifically with computing devices.
So what actually is a bug? What do we mean when we say that?
So a bug is a mistake. It's a mistake by the creator of a piece of software, and in some less common cases, a piece of hardware. A bug is a mistake that was made that is going to later on lead to an error. And the person who unfortunately is going to experience that error is going to be the user of that computing system. So it's a mistake that was not necessarily made by the user, it's a mistake that was made by the developer.
So bugs just happen because the developer didn't do a very good job?
Well, in a lot of this podcast, we've talked about what it takes to create software. And to a lesser extent, we've talked a little bit about hardware. And it's difficult. There's a lot that goes into it. It's a really sophisticated engineering discipline. It takes years of study and a lot of practice before you can get pretty good at making software or hardware. In fact, even when you have a lot of experience, it's still as much an art and an engineering discipline as it is a science. The discipline of creating computing systems has not been so perfected that we're able to do it in a very exacting way such that we can be sure, provably sure, that everything is working correctly in most cases.
There are different types of bugs, though. Can you go through them?
Yeah, I think we'll talk about 3 different kinds of bugs today. We'll talk about software bugs, which are the most common. Then there are also hardware bugs, which are pretty uncommon. And there's also design bugs, which actually are somewhere in between.
So tell me about a hardware bug.
Hardware bugs are relatively unusual. We want hardware to really be perfect when it gets out there because we can't change it once it's out there. So you're kind of stuck with the microprocessor that's shipped in your computer. You can go and upgrade the software, you can go and install a new version of the operating system, but you can't go and ever change the microprocessor unless you're going to go buy a new physical device. So we have to be pretty certain that hardware is working correctly, and we go through a lot of verification processes at hardware manufacturers to ensure that they're stress tested and will work under many different kinds of conditions. However, there still are hardware bugs that happen. There was a famous one in the mid-1990s that happened to one of Intel's Pentium chips. It made a wrong calculation. And that wrong calculation would be triggered not all the time, but often enough that they actually went and recalled the microprocessors. You don't hear about that much because, again, they want to be really careful. But hardware bugs do happen, and when they do happen, they're much more devastating in many ways than software bugs because it's very hard to fix them. We have to either go and replace the physical product, or we have to write a software workaround. And when we have to write a software workaround to get by some kind of hardware bug, it often leads to a degradation in performance. And so hardware bugs are something we really want to avoid, and I have to say the industry has been pretty good as a whole at avoiding them.
So then we have design bugs. Tell us about those.
Design bugs have to do with how a user interface or the way that a piece of software was meant to be used can lead to an unintentional error by the user. Of course, as human beings, we make mistakes all the time. But what if some of our mistakes were caused by an unintuitive system? A system that was set up in such a way that it was almost going to cause us to make a mistake. Now, it doesn't mean that there was actually something logically wrong in the software, but there might have been something that was presented to us in a fashion that would lead us to click the wrong box or type an unintended entry. So it might be that if we had really thought about it carefully and, really analyzed what was on the screen, we would have used it correctly, but it was made in such a way that it made it too easy for us to make a mistake. So we might call that a design problem. And a discipline within computer science that really looks at design problems is human-computer interaction. And a big part of that field is kind of studying how sometimes interfaces can be set up in such a way that they lead the user astray.
All right, so that leaves us with software bugs, the main category of bugs, you would say.
Yes, software bugs are the vast majority of bugs. And there's really two kinds of errors that can ultimately happen or problems that can happen as a result of software bugs. One is some kind of negative outcome for the user in terms of their data or in terms of their enjoyment of the program. And the other kind is security vulnerabilities. So a lot of software bugs lead to security vulnerabilities. And these, of course, have been more and more notorious as the internet has become more and more a part of every facet of our lives. And we all hear about them in the news regularly. We hear about security exploits. And if you want to know more about cybersecurity, we did a previous episode, What is Cybersecurity, with Professor Dwayne Dunstan, and I'll put a link to that in the show notes. But needless to say, security bugs are the bane of a lot of the modern enterprise software industry.
So as a user, how do you know if you're encountering something that is a bug?
You know you've run into a bug when something doesn't really run the way that it was intended to run. And so how do you know that? Well, there's the obvious things, right? The program crashes. Anytime a program crashes, that's by definition a bug. Programs should never be crashing. So the most obvious bugs, of course, are crashes. Other obvious bugs are sometimes told to you by the programs that you're using. So you'll get a dialog pop-up that tells you something went wrong. As software developers, we actually purposely put this in as kind of a defense mechanism throughout our software. Two reasons. One, we want to tell you something's going wrong so you're aware that this is not the intended behavior of the program. Number two, we actually want to give you a useful error message so that you might be able to fix the problem or at least report back to the developer of the software what went wrong so that they can recreate the problem and fix the problem. So those are the obvious cases. Slightly less obvious is when something just doesn't work the way that you intended it to. So for example, let's say you're playing a game and it slows down at some point, right? Does that mean that the game was actually under so much pressure given the hardware that it was on that it couldn't perform fast enough? Or was that actually caused because a mistake was made in the programming of the game that led to that performance degradation? Sometimes it's a little harder to say. So these more kind of subtle bugs are harder to detect, and therefore software developers need to do everything they can to prevent bugs in the first place.
Well, that's a good segue into our next topic, which is how do programmers prevent bugs?
So there's a lot programmers can do. There's both engineering and development practices that can go on to try to prevent the creation of bugs in the first place. And then there are also techniques while programming that can prevent bugs. So I'll start with some development processes that people can use. One is just peer review. So you write some code and you make sure that somebody else reviews the code before it gets into the product. Now, there's a form of massive peer review called open source software. And we actually talked about this in a prior episode that I'll link to in the show notes. But there's a law in open source software that was coined by Eric Raymond called Linus's Law, named after Linus Torvalds, who created the Linux kernel. It goes like this. With enough eyeballs, all bugs are shallow. The idea being that if enough different people are reading a piece of source code, it's less likely there'll be bugs to begin with. So there might be some benefits to a piece of software being open source for it to maybe have less bugs, you could argue, but there also might just be benefits from just generalized peer review. So even if you're a closed source piece of software, having other people at your company take a look at the software before it gets published, take a look at the source code before it gets checked into the main repository for the software, that can really be a defense mechanism against a whole class of bugs. So that has to do with development processes, and then there's also ways of tracking bugs within a company. Oftentimes you have bug trackers like Jira or GitHub issues that are used for keeping track of what bugs have been found so far, who's working on them, when do we intend to fix them, what patches are being made to fix them. So having some kind of sophisticated bug tracking system as part of the development process is typical of any modern piece of software. There are also whole ways of thinking about how you go about the process of making the software. One is called test-driven development. Here's the idea. You develop the tests for ensuring the software works correctly before you even develop the software. So it's almost like the tests become a specification for pieces of the software. Testing in general, though, is a very important aspect of reducing software bugs. We could do a whole episode on testing, but one very common and important piece of the testing philosophy is what are called unit tests. This means you take subsections of the software in isolation and you verify that they work with different kinds of inputs. So you have some expected kind of output and you test that slice of the software and see what its output is against what your expected output was. And you can have really great automated sets of these unit tests for large swaths of your code base. So for example, every time a developer goes and changes even just a few lines of code, all of these automated tests can run to make sure that the software still works the way that it was intended to work. Now, the tests are only going to work as well as they were designed. So of course, if you have bad tests, then you're not really verifying very much about the software. So testing is a critical aspect of trying to reduce bugs. So we talked about different design methodologies, organizational methodologies, and testing. Then the other big part might actually be programming techniques. And that's a little more technical than I think we can get into in this podcast. But I will mention actually the use of different kinds of programming languages. So there are some programming languages that are more designed for safety. And there are some programming languages that really let developers shoot themselves in the foot and are not going to stop them. So there's whole classes of programmer errors that can be basically eliminated by using certain kinds of modern programming languages. And some programming languages were specifically designed to reduce programmer error to the point that the language could be used in some very secure and safety critical industries. For example, there's a programming language called Ada. Ada has a lot of security mechanisms built in, and it's been pushed a lot by the US government for use in the military, and it's also been used a lot in the aviation industry. These are industries where we need to have as fault-tolerant software as possible. We need to have as few bugs as possible. I mean, we all know about some of the tragedies that have happened both in the nuclear industry as well as in the aviation industry as a result of software bugs. And so using a language that's not even going to let some of those bugs happen might be a great way forward. And so there's been a lot of movement of this, not just in those specific industries, but in the software world in general. Some newer languages such as Rust and Go and Swift all have a lot of built-in safety mechanisms to stop the programmer from shooting themselves in the foot that older languages like C and C++ just don't have. So we can eliminate a lot of software bugs potentially by moving to these newer languages, but there are other trade-offs to consider as well.
So let's say the programmer does all of these things, right? Has made their software. There still could be bugs, right? A programmer is just a human working on something. What can they do to fix a bug?
So the first part is really about tracking. So we need to actually know that the bug occurred. Now, some bugs we get from user reports. So maybe a user emails us or contacts us on social media and says, hey, I ran into this problem. That's fine. But what's even better is if we have automated tracking of bugs. So we've all seen this. A program crashes and it says, do you want me to send a crash report to the developer? This is really helpful because it's not then just based on the developer trying to recreate what the user told us happened, but we can actually see what's called a stack trace, which is basically a history of what the program was doing at the time that the bug occurred. And so we can look through these automatically generated reports and try to recreate exactly what happened at the time that the bug occurred. So having these kind of automated trackers in our software really does help in the development process. Okay, so assuming that you've actually successfully tracked the bugs and you're getting these automated reports and these reports from your users that are more manual as well, actually fixing them is a huge part of the software development process. And we sometimes call this phase of software development maintenance. The maintenance phase can actually be as time-consuming and intense as the original development phase of the software. Once we actually know about a bug, actually going and tracking it down can take a lot of time. Once I spent 24 hours trying to find one stray comma and fixing it. I didn't know that the bug was caused by that stray comma, but I was working in a large code base of my own, and it took a long time to figure out that one stray comma was causing this subtle bug. So tracking down bugs is actually, for a lot of people, some people enjoy it, but most programmers don't really enjoy it that much. And unfortunately, though, it's a lot of the software development process. One thing we didn't talk about is how we can try to actually eliminate some of these bugs when the software is out there, but not yet finalized. And sometimes we call that beta testing. This is the idea of getting your software out in the public's hands, or maybe just to some internal users or friends and family, whatever, and having them actually use it for real tasks. But you know that this is not yet a very polished piece of software. This is not yet a piece of software that you're proud of, that you might put a 1.0 label on, that you might sell commercially. And so if we're just going to have that software out there for anyone to find bugs and report to us, we call it a public beta. And if it's just going to be our friends and family, or even just the people inside the company, we call it a private beta. And there's even software that sometimes we say comes before a beta that's so rough that we really don't want a lot of people to use it yet, called alpha. And so you have alpha testing sometimes, and you have beta testing, and then finally you get to the final version. So we hope to kind of detect these bugs before they end up leading to embarrassment at the point of a final release version.
Sometimes, though, bugs do make their way through, right? And that's where a software update can be really useful.
Yeah, and we're really fortunate to live in the era of everyone having internet access. Because we live in this era where when you make a mistake, it can actually be patched. We don't have some of the huge pressures that earlier software developers had on them. We talked in a previous episode about when a Nintendo cartridge would come out on our episode on video game distribution, which I'll link to in the show notes. It had to be perfect because there was no internet updates. If that cartridge and that game didn't work exactly the way that the developers intended it to, there were no fixes, and it means your company was going to lose a lot of money because of that bug. Today, some software developers are almost notorious for putting out shoddy 1.0 products that end up getting fixed in many patches as time goes on. But this was not just true in the gaming industry. This was true in the regular software industry too. If you were just buying software for your PC or your Mac in the 90s, it would often come on a CD-ROM or floppy disks. And again, if you didn't have internet access, there was no way to get an update for it. So you were stuck with whatever came on that original floppy or that original CD-ROM. So people had to be a lot more careful back then. There's kind of this moral hazard today of, because we can fix something, maybe we don't put out as good a 1.0 product.
You and I had a unique experience with a software bug a few weeks ago.
Yeah, you were getting up in the middle of the night to feed our baby, and it was like 3:30 a.m., and suddenly you had a problem with your iPhone. You want to tell everyone what happened?
Sure. I plugged my iPhone using a charger I've used multiple times. The cord from the charger is actually an Amazon Basics. It was into the charger itself, which was an Apple charger. And I got an error message that said accessory not supported. But the error message wouldn't go away no matter if I hit OK or dismissed or unplugged the cord. And the screen itself actually was pretty much locked. I could move stuff behind the error message, but couldn't select anything.
Right. We could move things by bringing up Siri or if you held down the power button on the side because we wanted to turn it off, right? The slider to slide it off would come up, but you couldn't tap it. So nothing behind the accessory not supported dialog could be tapped. And the accessory not supported dialog could not be dismissed, no matter how many times you pressed OK.
So we were trying to turn the phone off, and we were holding down the two side buttons. And what wound up happening because of a different setting is we wound up dialing 911.
Yeah, so on really old iPhones, and I've been using the iPhone since the iPhone 3G, you would hold down multiple of the available buttons and it would lead to a forced shutdown. So I thought, well, why don't I just do the same thing? So I held down the power button and the 2 volume buttons. And apparently there's a new mode on Apple's iOS that's called SOS mode. And this was triggered. And what it does is it automatically calls 911 and it sends emergency notifications to all of your contacts.
Well, to your contacts that are set up.
To your emergency contacts.
Yeah.
Sorry. And so we tried doing this because we were trying to shut the phone down. And what we ended up doing was actually getting into this mode that then we couldn't shut the phone down from. So we couldn't tap anything on the screen. So we couldn't dismiss anything. And we couldn't turn the power off because we tried holding down the power button and we couldn't do that either. So we didn't know what to do. And so we tried like furiously to look up, like, what do you do now? And we found an Apple support article that said, well, hold down the power button. There was another support article behind that in the frenzy we didn't click on that said, well, now there's a new way of forcing a shutdown, pressing first the volume up, then volume down, then the power button. But we didn't get to that in time. In the meantime, 911 had automatically been called. So the 911 operator comes on the phone, and because we can't tap anything on the screen because this dialogue bug is happening, we can't dismiss the call. And so we have to talk to them. And so we say to them, like, listen, we didn't mean to do this. This was an accident. Like, we're really sorry. We're sorry we're wasting resources. We're really sorry. This was a bug on our phone. And they said, well, you know what? Because you might be being coerced right now. They didn't say this at the time, but we have to still send somebody. They just said we have to still send somebody. And we kept saying, please don't send anybody. But they sent people to our house. So 2 cop cars showed up and I went outside and I said, listen, this was a phone bug. And they didn't really understand what I was saying.
I showed it to them.
We showed it to them, though. And they said, listen, we didn't know when somebody calls whether or not they're being coerced by, let's say, a robber in the house with a gun saying, hey, listen, tell them that this was a mistake, that you were calling 911. And so we have to come by. So anyway, this iPhone bug of this accessory not supported dialogue not being able to be dismissed eventually led to the cops at our house at 3:50 a.m.
Luckily, though, the baby did not wake up. And I should say, just a reminder, because we had been connected to 911, we couldn't hang up, because even if you are connected to 911 and hang up, they would still send police.
Right, but we wanted to hang up. Yeah. That's the thing. We were trying to hang up. We were trying to shut down the phone, but because this bug made our phone screen inoperable, there was no way to get out of this mode. Anyway, I mean, we feel terrible that, police resources were wasted that night, but, we're lucky in that there's been much worse software bugs in history. Mm-hmm. I alluded to some of them earlier, but of course, some people say that the 737 MAX disaster, in fact, a lot of people, including many of the investigators, was really caused by a software bug, and that led to, of course, a lot of people dying. In the past, there's been mistakes made on radiation machines, software bugs that led to people getting too much radiation and dying as a result. So software bugs are not just an annoyance. They are a critical issue in the software industry. And we earlier just mentioned all the security vulnerabilities. I mean, think about the billions of dollars of value and millions of human hours lost to some of these security vulnerabilities. So we have an incentive as an industry to try to reduce the number of bugs. But I would say, just for all the people listening out there who are just software users, it actually is really important when you agree to send back those bug reports automatically to the developers. And you know what? You should demand developers fix the bugs, because if you don't, then they're going to keep getting away with putting out shoddy software. So all of us, both as users and as developers, need to work together to ensure the industry gets to a point of reducing the bug count. All right, well, thanks for listening to us this week. Rebecca, how can people get in touch with us?
We're at Kopec Explains, KOPECEXPLAINS on Twitter. Let us know if you have any topics you'd like us to talk about.
And don't forget to hit that subscribe button, and we'll see you next week.
Thanks for listening.